Thank you, Isabel. So,
Hello.
in this presentation, hello? Okay.
Okay.
In this presentation, Caroline, Jenny, and myself are going to present you some key informations about health and safety related to additive manufacturing, and particularly specific aspect in link with this new technology. Caroline is health and safety specialist at Bureau Veritas. And Caroline, do not hesitate to interrupt me to complete the presentation or to correct me if I'm wrong.
Oh, no, I don't think so, but no problem. I will complete.
So, first of all, First of all, what are the objectives of this presentation? Additive manufacturing is a new technology. It means that a lot of new issues will occur during the development process. Among these issues, we naturally find issues related to health and safety, to environment, and in consequence, knowledge and competence necessary to find appropriate solution. In this short presentation, we propose to review the main issues on health and safety through 3 questions. What are the risks for health and safety? What kind of solution could be implemented and established to prevent or avoid risks? What are the recommendations of Integradde based on pilot line experiences?
Just to complete, to add something, I think it's very important to think about health and safety from the beginning and not after the start of the project, because when everything is installed, the equipment and so on, it's much more difficult to deal with the health and safety question. And it's better to think about all these questions before starting to put some equipment somewhere. Okay, I let you go further, Laurent.
As a general consideration, a risk is a combination of danger and probability. If we try to define what we mean by danger and probability, we would say a danger or hazard is an action impacting people and environment. For example, an explosion is a danger. A probability is a frequency of or likelihood of occurrence of an event. Risks are often classified in categories and organized in a criticality matrix. Such as the one shown on the right of the slide, and in the horizontal axis. You put the probability from frequent or probable to extremely unlikely, and on vertical axis the severity, easy to say, impact on people and environment, from a level known or negligible to catastrophic or lethal impact. The combination of probability and severity provide a risk level, here represented in 3 colors. Red means high level of risk, green a low level of risk. What is important to avoid is to avoid or reduce level of hazard, and to do that it's necessary to identify risk sources. It is to say what could potentially go wrong. In a first approach, we can identify sources such as material, for example, wire, fine powders, gas released, process, machinery, temperature, electrical transport and manutention, and people, operators and users. The art of risk evaluation is complex. And we have at this stage 2 questions to answer. How to evaluate the risk? According to what standards or regulations shall we evaluate risks? Next slide. So the question is how to assess risks. As mentioned in the previous slide, risk assessment is not easy. First of all, it is necessary to have a detailed comprehension of the whole additive manufacturing process and also of the environment in which people, machinery, and material are playing. But it also needs an assessment of the likelihood and severity of events. It shall be done for each event occurring due to each source of danger. An internal standard proposed on the right side of the slide provide a methodology that can be used in our situation. This standard is mentioned here, ISO 12100, and it is important to have in mind two important facts. First, this standard is not specific to additive manufacturing and shall be correctly implemented. Second, a risk analysis shall be periodically updated. This methodology proposes different steps involving different specialists or actors involved in the AM process. What are these steps? First, take an inventory of hazards and necessary input data. These data are related to material, process, manufacturer feedback. Next, take an inventory of rules and regulations to be applied. This step complete input data inventory by placing these data in a set of external constraints. After that, it's necessary to identify the potential sources of hazards. It consists, in fact, in drawing up an inventory of dangers, an inventory of hazardous situation exposures, and complete this inventory with a risk estimation and quotation. The next and crucial steps is the identification and selection of tools to manage or eliminate risks. The risks shall be considered as at different levels, such as process, plant, organization, waste management. The result of the assessment is the selection of the best solution concerning prevention and protection. Choosing the best solution is always a compromise between several constraints such as cost, efficiency, capability, and so on. And obviously, the implementation of a prevention and protection action plan needs surveillance, measures, tests, corrective action in order to readjust the global efficiency of the plan and to reduce the global level of risks.
To complete what you say, I think what is really important is to review very regularly all this evaluation, this assessment, because each new product or each new equipment coming could change, and also the equipment from the beginning are sometimes very good safety part, but year after year the equipment are changing for the process or any other reason, and it's important to see if the level of safety is still the same, or if you need to put some more prevention or protection because something has changed. And also it's to maintain the materials, the equipment, and as we will see, some prevention and protection material that need really to be maintained in the time. A fan who deal with any dust or things like that must be maintained every day and control every year to be sure that it's still effective. So,
thank you, Caroline. Next slide, Isabelle. To reduce a level of risk, the better way is to eliminate it, or at least reduce it. A risk is eliminated if the source of danger is deleted or removed. For each danger,
Yeah, just to complete, that is the first point, is to think from the beginning if the risk must be there. Perhaps we can use a product less dangerous, less hazards, with less hazards. So we should go from the beginning to this solution and not use a solution will implicate a lot of risk. Yes.
For its danger, the risk analysis has been conducted to identify source and cause of each dangerous situation. And this step is really key and shall be performed carefully, neglecting any cause. Human causes, machinery causes, energy sources causes, environment causes. The process should be systematic with an appropriate traceability. The efficiency needs to prioritize the most critical dangers and to remove most critical causes. Each risk should be taken into account. Preventive action and organizational action should be prioritized because industrial feedback brings to light that human interaction is more often the main cause of danger. Concerning the protection of people, collective protection shall be prioritized, implemented before individual protection. And to each specific danger, appropriate individual protection shall be proposed to operator. The management shall also consider health and safety measures such as training, information, KPI, and so on. Nevertheless, we know that zero risk does not exist, and it's not possible to issue a perfect risk analysis. In consequence, it's more than prudent to prepare emergency measures in order to mitigate the effect of emergency. And as I mentioned previously, it's important to update periodically your risk analysis and your protection plan.
And just to complete, there is a ISO proposed as methodology, but each country can propose some methodology. In France, there is INRS, which is proposing some methodology in the same with the same idea of this one, and there is a regulation by country to oblige to do this document listing all the risk and all the measures you put on every risk to limit the danger for the people working in your activity. And also take care about PPE. It's very important to choose properly the PPE. It's not we need gloves, but not all gloves are correct. So it's just not the selection of PPE is something very important also.
Next.
Yes. Sorry.
Risks can occur in many different ways from various sources, particularly because environment is continuously evolving. The risk management is a prioritization process whereby the risk with the greatest loss and the greatest probability of occurring are handled first. So risk management implies organization and policies, and clear rules shall be established. This set of rules and decision includes inventory of hazardous substances in a periodic way, regulatory and normative watch task usually assigned to the risk management team, health and safety procedures, also under the authority of a safety officer or safety manager. Prevention plan, which is regularly reviewed and updated. Maintenance of collective protection and management of PPE. Management of event and accident. Each accident is a lesson learned, and the root cause analysis shall be made and used to improve organization and procedure. It's really important.
Yes, and the root cause analysis could be done only for events. We should not wait for a real accident and a big accident to analyze the causes of these events. And that will be the best way not to have accident.
It's also necessary to have an internal and external control policy and control audits. Have in mind that a critical A is always useful, and that what is important to note here is that, in conclusion, that HSE policy shall be included in continuous improvement loop. It's never finished, in fact. Slide 8. What are the main possible risks on Earth? Because it involves machinery, materials such as gas and power, energy sources, high temperature, material handling, and so on. Additive manufacturing is an activity that presents some risk on Earth. And the purpose of this slide is to draw your attention on the fact that identification of induced risk on Earth is not so easy and needs the involvement of an HSE specialist. Another key.
Yes.
Sorry.
During the AM process, the materials are changed and are heated, and there is many chemical reaction produce, and so it's really important to go further in what's happening, to know really the risk of toxicology of different products.
So in this slide, some risks are mentioned. For example, toxical hazard, chemical hazard, risk due to power, risk in link with machinery, energy source handling, and so on. And the induced risk could be some products released during the AM process, certain gas produced during the AM process, and so on. Another key information is that rules and regulation about health and safety protection is usually defined at local level. If ISO or AN standard exist, in most cases, you have to take into account national regulation. Hazard identification now. So hazard identification concerns on one side material and products, and on the other side site processes. For machinery, European directive provides general provision to reduce risk and prevent from most dangers. For products, REACH regulation provide also detailed recommendation on use. It's important to highlight here that safety data sheets are maybe the most reliable information resource to manage hazard identification for products, for material. Once again, safety data sheets are not specific to additive manufacturing, and to complete this approach, in the next slide, we will focus on the risk in direct link with additive manufacturing.
It is important to learn how to read this safety data sheet and how to catch the good information in this document. So don't hesitate to do training on this aspect. Yeah.
Okay. Focus on specific risk in link with AM. Materials used in additive manufacturing cover a very wide range from plastics such as nylon to metals such as stainless steel, titanium, aluminum, and their alloys. Most of these materials are combustible and therefore explosive where they are on powder form. Some metals such as titanium and aluminum can burn very fast and produce extremely high temperature and pressures. It needs very specific safety measure and caution. Some metal like titanium, for example, requires special mention for the high explosion index. So the hazard can appear at different steps of the AM process. First, during the receipts and packaging, storage of the materials, during the transfer of material, during the manufacturing in itself, during the cleaning of the filters, during the recovery of unused material or the cleanings of the parts, and during the finishing process. Next. Powder can obviously have a direct and serious impact on health and especially on the respiratory system. In this slide, two tables present the general risk approach with powder. On the right, a table proposes a classification of chemicals according to their level of dangers. On the table below, impact on Earth in link with the particle diameter. I do not go into detail, but what this tables show. So if the grain size is maybe the main parameter, it's necessary to take into account concentration level in the atmosphere. As a result, risk is a combination of physical hazard, size of the grain, and the particles, and chemical hazards.
Yes, and the dust diameter is also important for the ATEX risk, so the explosion risk. So and most of regulation give some level of dust acceptable or not in an atmosphere of works. So in any case, the dust, even if it's not a really toxic product, are very dangerous for people and the health.
So additive manufacturing is above all an industrial process. So in this slide, I propose a short focus on the on risk not specific to additive manufacturing. Sorry. So first, we have the risk of excessive pressure, covered in Europe by the Pressure Equipment Directive. The electrical risk also covered by a European directive. The risk of explosion, particularly covered by ATEX directive. The risk in link with machinery safety, covered also by one of the oldest European directive. The next one is not really specific to additive manufacturing, but it's really important because of additive manufacturing machinery needs inert gas. In that case, the anoxia risk is real, and anoxia is particularly insidious. And most classical, the risk of falling, handling, cutting. Other risks that should not be overlooked as risk in link with noise, crushing, projection, hazard. Fire hazard is due to specific source of heat and provoke major burns. And we have also for process involving laser a risk with optical radiation.
What we can ask is all mechanical hazards are also a big risk that could be cutting or crushing or other because materials are automatics most of the time, and it's really important to have in place some procedures to lock out, to tag out any equipment when accessing an equipment, to be sure that equipment could not start alone and hurt people working on it during a calibration process or things like that. People want to be in contact with the equipment, and it's really important to be sure that the equipment does not start at this moment.
Next, the safety measures are established according to the result of the risk assessment and take into account the intended use of machinery and material and reasonably foreseeable misuse. For the implementation of the safety measure, ISO Technical Committee and ISC Technical Committee propose detailed guidelines on most aspects. Safety measures are classified in 3 principal categories: equipment protection and room design, organizational and collective protection, and individual protection. It's important to organize your safety measures, your safety measure strategy in this order. Current equipment protection and room design are machinery internal protection, for example, ATEX conception, air gas extraction, casing, and so on. Protection to transfer of device, handling and storage procedures, the control safety measure to manage the material flow design, secure storage room, control of inert gas used to avoid anoxia, procedure and clear user instruction for products and materials, thanks to appropriate labeling, access to premises with protection, confinement or locker. The premises shall be duly ventilated also and protected against fire risks. Organizational and collective protection. So access to premises and machinery shall be organized and limited to only trained employees. Procedure and training shall also deal with gas detection and anoxia gas detection system with local ventilation, devices and fire protection organization, and firefight capabilities. Individual protection concerned equipment such as mask, glove, and so on, but also safety instruction such as training, safety data sheet, and other informations.
And what is very important is that this safety measure should cover really the process on itself, but also the preparation of the process and all the other phases like cleaning at the end should be also covered by safety measures.
So, as mentioned at the beginning of the presentation, most risks are in direct link with human behavior. So, wearing its personal protective equipment is an habit to have, and everyone shall respect this rule and wear his PPE. In this slide lists some personal protective equipment. and there is no use reading this list in detail. What is important is to choose this equipment only if they are compliant with European or ISO standard and with real evidence of their efficiency.
Yes, and they should be chosen depending of the risk. So gloves with cutting resistance are not useful against chemical risk, and the inverse is also true. So it's really the choice of the good equipment is really important and should be adapted to the people to be sure that they really wear it at the good moment.
So if the safety of premises and equipment is important, this presentation would not have been complete without a focus on environment protection. Additive manufacturing is a way to save material consumption and energy. Nevertheless, it would be a mistake to consider that it's sufficient in itself. And an environment protection strategy should be put in place. It should include some important topics. If energy saving is a priority, an analysis could be used to help you to identify the AM process that propose the lower operating energy. It could be very efficient also to include in manufacturing process additional procedure such as the pre-heating of powders and parts. You can optimize the quantity of consumable by taking action on geometry, accuracy of machine, and tailored tolerance. The additive manufacturing process could be optimized also in itself in different way. Optimization of flows, design selection, reduction of confined volume, and so on. And last, don't forget waste management is a strong recommendation because AM produce nevertheless a lot of waste. So, in comparison with subtractive manufacturing, we can consider that additive manufacturing is environment friendly, and for different reasons. So it only uses just necessary material. It proposes the best strength versus the best material ratio. It allows important energy saving, cutting oil saving, and so on. Additive manufacturing allows new perspective in repair markets. We can say also that additive manufacturing makes possible the manufacturing of a lot of spare parts, even if the original manufacturer does not exist anymore. It is really important. And last but not least, additive manufacturing is much more competitive for small batch of products. So as a conclusion, we can say that additive manufacturing involves many risk sources. Risk managers shall be put in place. Fine powder needs specific attention. Local regulations shall be also considered, and the help of an external or internal expert is really key.